we are going to come in the very first chapter in science. So before going to that, just one special recall the chapters what we are going to learn in this academic year, in particularly in science. So you all know that science has been divided into three branches: physics, chemistry, and biology. So today, as I'm going to commence the first chapter in physics, hence I'll give you the information regarding the chapters what we are going to learn in physics in this academic year. So hope that you're all ready with your notebook. Okay, just observe. In physics, we come across many interesting facts, which some of you have already learned in your previous classes as well. If you want to recall them, you have learned about the light and some phenomenon related to light. It may be the new moon, then new moon, full moon, then sun rising, sun setting, dispersion of light. Is it not? So many interesting facts are there in physics. So this year also it has included such interesting facts, but the detailed information is collected in the chapters what we are going to learn in this academic year. The chapters that we are going to learn are, the very first one is, it is motion. Don't go for writing, just look here. The first chapter is motion. You are very familiar with the concept called motion. In previous classes also you have come across different types and many related terms also, and their extended parts are going to be learned in this academic year. Next, second one is, it is force and laws of motion. Force and laws of motion. In your previous classes also you have got information about force, types of force, is it not? Particularly the chapter called force and pressure, which I learned in 8th standard. Then the third one, it is another interesting chapter. This is gravitation. They will come across the concepts like why the planets are revolving around the sun and why satellites will revolve around around the planet, and why we are bound to the earth, why the particles in the universe they attract each other, in spite they attract each other, why they have their own position. Such interesting facts are to be discussed in the chapter called gravitation. Then fourth one is, it is work, energy and power. In your textbook this has been mentioned as just work and energy. Work and energy. Then fifth one is about the sound. You have learnt about the sound in 8th standard as well. So these are the chapters that we are going to discuss in physics. Is there any chapter which is not familiar to you? No. So all are familiar only, because you have come across all these concepts in your previous classes. Only their extended parts are to be discussed in this academic year. Dear students, now please take a notebook, physics notebook, and in index, please go for writing these chapters one by one. Yes, go for writing in index. First one, motion. Just leave space. Just leave one line. Next, write force and laws of motion. Next, third one, gravitation. Leave one line and write. Fourth one, work and energy. Again, go for leaving one line. Fifth one is, it is sound. Over. Listen, to cover these chapters, we will go for using some of the reference books as well, along with NCERT. The references that I am following are, let me write one by one. You can also copy that. One is regular, it is NCERT textbook. Second one is yes chance. Third one is all in one. All in one. Fourth one is Dinesh publications. And one more, it is Golden Guide. Golden Guide. These are the references which are to be used. Or you will be having the NCERT text. In future days, if you want to buy the reference book, for students, I prefer all-in-one. This is best for you. A brief information will be there in this chapter, in this publication, all-in-one. It is good for you all. Whereas in these, a lot of information will be there, so you won't feel comfortable. This is best one for all the students, all-in-one. Okay. Now, you go for writing the name of the chapter in regular pattern. Write in next page. In that page, they have given the margin like this, vertical and horizontal, just leaving 3 lines. Draw a line with scale and pencil. Next, here also, we can divide this into 3 parts. In the first part, write chapter number. Chapter number. This is 1. In physics, it is 1. Next, here you have to write the name of the chapter. The first chapter name is, it is motion. Next, here you can write date. Write today's date. It is 12/6/2020. 12/6/2021. Overall. So now let me go for rubbing this. Yes. Igna, should I rub this? Okay. Now let us commence the first chapter in physics. And before going to commence this chapter, let me go for showing you some pictures. Just observe. Just go through this picture. Then what do you think about it? You can tell that later. Just observe. Observe what all the objects are there in this. Here we have the tree. Here we have house, an electric pole, then here building, then here mountains are there. Observe this picture as well. Yes. Here we have the ship, then we have the car, a boy riding a bicycle, and here we have the train. See, from these two pictures, see here, first page pictures and second page pictures, you can come to know that we have plenty of objects. Some objects which are in the same position, they won't move from one place to another place. Whereas some objects are there, they can move from one place to another place. See that here, in this picture, the tree, house, very good, tree, house, then electric pole, building, mountains, they're all having the fixed position. They won't change their position. And when you compare the positions of these objects with respect to its surroundings, you can come to know that you can describe their position as rest. Is it not? They're all unmoving objects. Whereas these are the objects like a car, riding, a boy is riding a bicycle, then here train. They are changing their position continuously. Is it not? Here the body is changing its position continuously, which means that they're all moving. So from these two pictures, we can come to know that we have the objects. We have the objects which are at rest. We have the objects they can move continuously. So, and we can also come to know that there are two states with respect to any object. One is the state of the rest, and second one is state of motion. Then what is state of rest? Here again, I have to show this picture. When a body acquires the same position, or when a body does not change its position with respect to its surroundings, then we can say that it is at rest. Then when a body changes its position continuously with respect to its surroundings, then you can say that it is in motion. Now you tell about my state, whether am I at rest or in motion? Am I at rest or motion? I am at rest, no? Because I am not at all changing my position, so that you can say I am at rest. Now observe it. Just keep on observing. I am changing my position continuously. See that I am not at all standing anywhere else. Just I have been moving. As I am changing my position continuously, you can say that I am in motion. Followed? Followed? Yes or no? Yes. So when a body does not change its position with respect to its surroundings, or when a body acquires the same position at all the time with respect to its surroundings, then its state is said to be at rest. And second one, when a body changes its position continuously with respect to its surroundings, then we can say its state as state of motion. These are the two states of an object. So right, right, it is state of a body. State of a body. Body has two states. One is state of rest and second one is state of motion. State of rest and second one is state of motion. Once I repeat the definition, listen carefully. When a body does not change its position with respect to its surroundings, then it is said to be at rest. Next, state of motion. When a body changes its position continuously, then its state is said to be in motion. And if you want to know whether a body is at rest or body is in motion, you have to compare them. So hence we can say that rest and motion are both are relative terms. Then you all may be thinking that how they are relative terms. Dear students, let me go for giving you a situation with respect to this. Imagine that you are in the lift. You are in the lift and you are not able to see anything outside. You want to move from ground floor to some 10th or 11th floor. When it is moving, do you feel that you are in motion? See, as I said, you are inside the lift. You are not able to see any objects outside it. Just you are moving from ground floor to 11th floor. When you are in motion, my question is, do you experience that you'll be moving up? What do you say? No. Very good. Very good. Arashi, you won't take, you will not experience all of a sudden when it comes to 11th floor, when the door is opened, you will come to know that, yes, we are in 11th floor. You'll not experience. But assume that you are in the transparent lift. Like you might have observed that in BSE exclusive. You might have gone there. When you stand inside the lift, you can see the objects outside. Is it not? When you are moving up or coming down, you will experience that. Yes, I'm coming down or I'm going up. The reason is, in this case, in second case, it is possible to experience because you will compare your position with the position of surrounding objects. Whereas in the first case, you are unable to compare your position with your surrounding objects because you are not able to identify, you are not able to see the surrounding objects. Is it not? Hence, if you want to know your position, you have to compare the position of other objects. Therefore, we can say that rest and motion are relative terms. Dear students, you will see many objects which are in motion. Assume that a man is walking towards east, which means that he is moving in a straight line. And you will also observe the kids which are who are playing in the park. There will be a swing. So they'll play with that swing. So there you can observe it is to and fro motion. Is it not? And when you imagine that the giant wheel, you are sitting in one of the box of that giant wheel, then you can just experience the type of motion. Not only that, even if there is merry-go-round is there also you will experience a kind of motion. If it is Columbus, then there you will experience to and fro motion. And when you go to any temple, there also you will experience two kinds of motion. Is it not? That is, one, just you'll while praying the God, you'll start to keep moving on your position only, like this. Is it not? After that, you'll move around that idol. So from all these, you can come to know that there are different types of motion. Then what do you say about a body? What do you say about the motion if a body moves along a straight line? Very good. It is a linear motion. When a body moves along a straight line, it is called linear motion. You may take an example. As I said, a boy is riding the bicycle in a straight road. Got it? And the light, it travels in a straight line. See that here also motion is straight. And if a light travels in a straight line, and we call that phenomenon as rectilinear motion. Followed? Suppose you are riding a bicycle in a straight road. Then you need to take either right turn or left turn. Then you just go for changing the direction of motion of the bicycle. Is it not? If just keep on changing its direction, what will happen? You start moving in the curved path. If a body moves along a curved path or circular path, then we can say that it is circular motion. Example for circular motion, that is the type of motion experienced by you when you are in the giant wheel, right? Then the motion experienced by you when you are in the merry-go-round. Then you just observe the tip of the arm of the clock, maybe the minute hand, hour hand, or second hand. You just observe the tip. The movement of the tip will be in the circular path. Next, and the swing. Then when you sit on the swing, you start playing. Whether you move in the circular path, whether you go straight. What type of motion you will experience? Yes, it is to and fro motion, which is what we say oscillatory motion. And many times you'll go for playing with a scale, and you'll hold that, you'll keep that scale on the table, and you start leaving like this. Then it will, this to and fro motion will be very fast. What do you call that rapid to and fro motion? It is called rapid to and fro motion of a body. It is called vibration or vibratory motion. Are you following? So these are the different types of motion: linear motion, circular motion, rotatory motion, oscillatory motion, and even some motions are very complex. You are not able to tell what type of motion it is. Example, say assume that there is a slide. There is a slide. At the top of the slide, you are going to place a ball. You will give a gentle push to that. What happens? The ball starts moving along the on the surface of the slide. But what type of motion it is? Do you say that it is linear? Of course, as it is moving in a straight line, you can say that it is linear. At the same time, when the ball moves like this, or it will be rotating every time. This will be rotating. Here, two types of motion can be experienced. Got it? So such motions are to be considered as complex. And what are the examples I told? These are the examples for the motion of the object which can be observed directly. Movement of the ball can be observed directly. A man riding a bicycle can be observed directly. Then a moving bus can be observed directly. But the motion of some objects can be noticed indirectly. We cannot see them directly. For example, we say that the air, whether air is there or not on our surface of our earth, air is there. Then can we, if it is so, if it is there, can we see the air? Can you all see the air? No, you cannot. Then how do you come to know that air is moving? You will observe just by taking up. You'll just take a piece of paper and you start leaving. When you are leaving the pieces of paper, they won't fall to the ground directly. They'll be floating, which means that it is because of the movement of the air. Then when you just go for moving your hand fastly, you will experience, yes, there is air, but movement of the air. You can also come to know the movement of the air by observing the fluttering leaves of the tree. When the air is moving, because Because of the movement of the air, then leaves of the tree will be shaking. Are you following? Yes. Then have you seen, you all know that we are able to see the things around us. It is because of light. Is it possible to see the movement of the light? No. But how do you come to know the movement, the motion of the light? Very simple. When you observe the dust particles, you can come to know the direction of movement of the light. Following? Then now you tell that whether Earth is moving or not. Moving or not. It is moving. How do you come to know that Earth is moving? It is. You can come to know Earth is moving by experiencing the sun rising, sun setting, by observing even the movement of the, by observing the motion of the moon also, you will come to know Earth is in motion. See, these are the objects whose motion are to be observed indirectly. Got it? Followed? So from all these examples, we can come to know that motion of the objects can be, some objects can be seen directly and some objects can be seen indirectly. Okay, now just here again I am going to show you some pictures. Here an athlete is running in a straight track. Could you tell what type of motion experienced by him? It is. Prashant sir. Prashant sir. It is linear. As is moving in a straight line, you can say that the type of motion is linear. Next. Assume that here cheetah is chasing the deer. Assume that both are moving in a straight line. What type of motion experienced by both? It is also linear motion. Then what about this? Do you say that it is linear? Here you can observe that a boy is moving to the school from bicycle, but the path is not in a straight line. So it is not linear. Whereas in this case, observe, a batsman will hit the ball. Observe the direction of the ball and the position taken by the ball. Here it goes straight, then it takes turn, then take turn. It is circular. If it is moves exactly in the curved path, we can say that it is circular. In the same way, look here, assume that it is our solar system. Sun is at the center and all other planets are revolving around it. Then what type of motion shown by the planets? It is circular, not rotatory, circular. If one object moves around another object, it is circular. If an object moves on its own position only, this is called a rotatory. So these are the different types of motion. Now let me go for giving you the points. Please go for copying them. Right. First you got a state of a body. There are two states, and we also came to know that rest and motion are relative terms. Right. Rest and motion are relative. Both are relative terms. Then for this, we took an example of the lift. And even you can also go for taking another example, that is, listen, imagine that you are in the train and the train is moving with a constant speed. It is moving in a constant speed. You are inside the train and all the doors and windows are closed. At that time, do you experience you are in motion? No. Is it not? Are you following my words? Are you following my words? Very simple thing. I have given you the situation that the train is moving with a constant speed. It is moving with a constant, it is not at all changing its speed at all. It is moving with a constant speed. Yes. The train is moving with a constant speed. You are inside the train and all the doors and windows of the train are closed. No. Then my question is, do you experience that you are in motion?
No,
No,
sir.
sir.
No, sir.
No, sir.
No, sir.
Wait. Now, after that, you just open the window. Then you start observing the objects and you will experience, you feel that you will be moving forward and all other objects appear as if they are moving backward, even though the buildings are there. But for us, we feel that the building is moving, then the electric poles are moving, then stones are the big rocks are moving. We experience so.
Yes, sir.
The reason is,
Yes, sir.
from that you can come to know that you are in motion. Here it is possible because you will compare your position with your surrounding objects like trees and all. Therefore, we can say that rest and motion are both are relative terms. So regarding train also, this is another example. Next, we come across different types of motion. Right. Types of motion. Types of motion. One is, it is linear motion. Linear motion. And second one is circular motion. Circular motion. Third one is oscillatory motion. Next, periodic motion. Then translatory motion. Many are there. Rotatory motion. Just these three are enough. And some motions are complex. I have already given you that examples also. That is, complex motion means it is a type of motion in which more than one type of motion can be observed. I've given you example for that also. Then, and as I said, some motions can be observed indirectly. Right, that side A. Right, motion which can be observed indirectly. Just I'll give you the examples for this. It is the motion of A. Motion of A. Next, motion of Earth. Similarly, the movement of light. So these are few examples for the objects whose motion can be observed indirectly. Can you stop? Listen. Now let us go for, so far we got some information about the motion of the object. Let's come across the rest or the position of the object. Then how do you go for describing the position? Let me give you some examples which you come across oftenly. Suppose your friend is coming to your house, then you want to tell them address, and you will go for telling the address like this. You just come nearby the temple. From the temple, it is at a distance of just 100 meters. Or else you say that my house is nearby the Bapuji school. My house is nearby Thadabala school. Is it not? Means to describe the position of your home, you'll go for taking another object as a reference. Are you all following?
So reference point.
It's reference point.
Whatever the object we are going to use for specifying the position of another object, and we call that as a reference object or a reference point. Got it? If a boy tells that my house is nearby X school, then which is the object here?
X.
X.
School.
X.
Once I repeat. Look here. A boy is telling that his house is nearby a school. Here, to locate the position of the house, he will go for using a reference point. That reference point is the school building, and the object is house. Understood? And we call this reference point as origin. Got it? The position of an object can be specified by a fixed point, and this is known as a reference point or fixed point or origin. Here, origin is building, or reference point is building. Then house is an object. Followed? Okay. Next, I'll give you another example. There is a table. Don't go for copying anything. Here, some pens are there, notebooks are there. Then suppose you are going to search a reading pen. Here pens are there, reading pen, and your mother will tell that it is just beside book only, your notebook only. Then which is the object and which is the reference point?
Sir, object is book.
Object
Object is book.
Sir, object is book.
Pen. Object is
pen.
Pen is object. Reference is book.
Wait. You have to understand this properly. Look here. Again, I'll go for taking this example. House is nearby the school. To describe the exact position of the house, we will go for taking the school as a reference point. Got it? This is the fixed point which is used for locating the position of the house. Hence, we consider the building, a school building, as a reference point, and the house as object. Here, the pen is just beside the book. Then, which is
Book is reference.
The reference point.
What book is reference
Bookish.
Book is
Which
reference
is the
point.
object?
Object is
Pen.
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 Pen is the object. Book is a reference.
Right. Right. Pen is the object, book is also object.
No, sir, reference.
Book is reference point.
Sir, book is reference and
Sir,
pen
book is
is object.
reference.
Very good.
Reference point. Book is origin.
Look here. Here, pen is the object which is to be needed. We are going to describe the position of this pen. Where it is? It is nearby the book. So here book is to be taken as a reference point. Book is reference point and pen is an object. Followed? Yeah. Please go for writing the reference point. Side heading. Side heading, reference point. Right. Reference point. And in bracket you can write. It is also called origin. For this, I'll give you the definition. Please go for right. Right. The position of an object. The position of an object. The position of an object can be specified or described. Can be specified. Specified or described. Described. Can be described by a point or by a fixed point. Fixed point. This is known as reference point. This is known as reference point.
Sir said.
Listen. Look here. Listen. Many times when I'll be telling the address of my tuition center to the parent, I tell like this. Our tuition center is nearby the Lakshmi flour mill. Our tuition center is nearby the Lakshmi flour mill. Then could you tell which is the reference point and which is the object?
Reference
Reference is Lakshmi Foreman.
Academy.
Academy is object.
Wait. Well, Salik, could you tell which is the reference point?
Lakshmi floor mill.
Yes, Lakshmi flour mill, it is reference point. And the object is our tuition center. Got it? And I'll go for, yes. Asim, I'm going to give you another sentence. A boy, I'm going to describe the position of a boy. A boy is standing 5 meters away from the electric pole. Which is the object here?
Boy.
Ball.
Boy is
Boy.
object. Reference point?
Electric pole.
Electric pole.
Electric pole.
Did you understand?
Electric pole. Electric pole.
Enough.
Sir,
Vibha,
if
did you understand? Vibha?
Yes.
Have you understood? Okay.
sir, if like this in Vidyanagar main road, there is a Thalabadu school. Beside that, my house is there. Both will be the object, sir.
Wait. Who is speaking?
Prajwal, sir.
Prajwal. Yes, tell now.
Sir, like this, in Vidyanagar main road, there is beside that Thalabadu school is there. Beside that, my house is there. The object will be both, sir.
The object will be your house and
Road.
reference point will be Thalabada school. Because your means it all object is to be considered. It depends on which is going to be described. Followed? Are you following? Which is the position of the thing is which is going to be described, that is to be considered as an object. To describe that position, another object which you are going to take is to be considered as
Reference point.
point.
Reference.
Sir, reference point can be two, sir.
Pardon me?
Sir, can two objects be reference points, sir?
Of course, it may be. It may be. I'll give you an example for that. Suppose your home is in MCCB block in some cross. Got it? Then in MCCB block we have Mama's Joint Road. Then there is also Dental College Road. And straight to the Dental College Road there is Gundi Circle. And you will tell address to your friend that you just come to Gundi Circle. From there you come straight again, turn to Mama's Joint Road. Look here, to describe the position of your home, you have used two fixed points. One is Gundi Circle, second one is Mama's Joint Road. So they are to be considered as reference points. Did you understand?
Yes, sir.
Okay. Dear students, now I'll go for taking some measurable quantities, or some quantities can be measured. Could you give some examples for the quantities which can be measured?
Speed,
Yeah, very good.
Velocity. Velocity.
Velocity,
Distance.
speed, okay.
Acceleration.
Acceleration.
Density.
Enough. But generally, the public do not know about acceleration and all. Is it not? They may be, commonly they'll go for using the word speed. But do they use velocity?
No, sir.
No. Let us go for taking some commonly used quantities which can be measured. Like you can Kaula shake. Listen. You can go for checking your weight. Weight can be measured, and the distance for which you can walk or you can run, you can move, that can be measured. Or if it is a study table, or the area of the table can be measured. Its weight can also be measured. Length can be measured. Breadth can be measured. Got it?
time,
If you go for taking an object, its volume can be measured. Time can be measured. So all these are measurable quantity. Do you know what we call these measurable quantities? What do you call these
scalar
measurable
quantity,
quantities?
Scalar quantity.
scalar quantity,
I tell you that. The quantities which can be measured or the measurable quantities are known as physical quantities. Followed? Physical quantities. Once I repeat, the quantities which can be measured are called physical quantities. I'll go for giving some example. Please don't try. Keep on observing. Keep on observing. Length can be measured. Area can be measured. Volume can be measured.
Time.
Weight can be measured.
Time.
Mass,
Time.
distance, time, force. See, all these are
Speed.
measurable quantities. And these measurable quantities are known as physical quantities. And all these physical quantities can be classified into two groups. Just I go for giving you the examples. Repeatedly I've been telling not to go for writing. Just look at the board. Look here. Here, I'm going to write the time. Next, here I'll write weight. Here I'll write force. Here, I'll go for writing area. Okay. Two groups of physical quantities are taken. Two groups of physical quantities. Here, I'll go for writing one mass. Observe time, area, and mass. These are physical quantities in one group. You can say that. You can say the time. It is 8.15 a.m. Then 2.15 p.m. Like this you can use. Area.
They need magnitude, sir.
Surface. You can say that it is 1 meter square. It is 10 meters square. Like that. Mass. You can also tell that mass as 10 kg, 20 kg, and so on. Here, when you are describing about these physical quantities, you are using the numerals as well as the units. Example, if I take area, it is 20 meters square. 20 meters square is the magnitude of area, which includes the value as well as the unit. Observe this. Force. Let us use. Let us take the force as we are applying a force of 10 Newton. 10 Newton on an object. 10 Newton is the magnitude of force.
Force.
Can we mention the direction? Can we mention the direction of force that we have applied?
No.
Yes, sir. Yes, sir.
We can see that if I apply
sir.
force like this, I am applying the force on an object away from me. If I am pulling any object, again I have to apply the force. I am applying the force towards me. Got it? Here direction can be mentioned. Is it possible to mention the direction of?
No, sir.
No, sir.
No, sir.
No, sir.
No, sir.
No. Okay. These are the physical quantities. Time, area, mass. These are some physical quantities having magnitude only, no direction. Yavudaku direction illa. Whereas force, weight, these are the physical quantities having both magnitude and direction.
These
So
are
based
called
on this, we can classify physical quantities into two types. One is a physical quantity having magnitude only, no
Scalar.
direction. It is called scalar. Physical quantity. And the physical quantities having both magnitude and direction, they are called
Vector.
vectors. So these are two types. Understood or not? Yes. Okay. Now you write side heading physical quantity.
Sir, explain weight, sir. Sir, explain weight in vector.
Wait. I'll go for explaining weight. Observe it. Look here. Look here. Don't read. Just look here. Regarding weight, you have got information in 8th standard only. I'm going to take the same concept. You got information about weight in the chapter called force and pressure. We will go for defining the weight like this. Okay, this is here is an object. Weight of an object. Look here, Lakshmi Shri. Look at. You are going to describe the weight of an object. It is the force exerted by the earth on this object, and this force is directed towards the center of the earth. Got it? Here, if you are standing here on the earth means Earth is exerting the force on you, and that force is directed towards the center of the earth, and we call it as weight.
Gravity.
The force exerted by the earth, on an object is directed towards the center is known as weight. Got it? So the unit of weight is Newton. ನಾವೇನ್ ಮಾಡ್ತೀವಿ ನಮ್ weight ಅಂದ ತಕ್ಷಣ yes I am 40 kg, I am 60 kg ಈ ರೀತಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Actually unit of weight is Newton, and it has the direction. Now wherever you may stand on the surface of the earth, the force exerted by the earth on us is always towards the center of the earth. So direction is also there, as weight has both magnitude and direction, therefore it is a vector quantity. Artha aita? Yes.
Sir, what is Newton?
What is
Newton.
Newton? It is the unit used to measure force. Iga example, suppose you want to you want to buy some amount of rice. Amount of rice antandanga you go to the shop and you will ask just give 5 kg of rice anta keltiya athwa give 5 rice anta keltiya. 5 kg of rice alva, kg ಏನು indicate ಮಾಡುತ್ತೆ? That is the unit which measures that quantity. Got it? ಈಗ 1
Sir,
liter
we may say SI units, sir, for that.
yes
We may say SI units for that, sir.
yes system of international unit. ಆಮೇಲೆ ಮತ್ತೆ ನಾನು ಡಿಸ್ಕಸ್ ಮಾಡೋಣ ಯೂನಿಟ್. ಇದನ್ನ ಯೂನಿಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಫಾಲೋಡ್? Go for writing the definition of physical quantity. It's important.
The quantities which are measurable.
The measurable quantity, or else the quantity which can be measured. The quantity which can be measured. Is called physical quantity. A quantity which can be measured is called physical quantity. Give some examples for that. It is length, area, weight, speed, volume, time, force, pressure, etc. Next, studying types of physical quantities. Types of physical quantities. Types of physical quantities. So there are 2 types. Right. The types are, one is scalar quantity and second one is vector quantity. First one is scalar quantity, second one vector quantity. Please go on writing with me, don't be lagging. Now in that, write first one scalar quantity. Write its definition. It is the physical quantity that has magnitude only. The physical quantity that has magnitude only. is called a scalar quantity. A scalar quantity. Give examples for scalar quantities. They are, you can say that, time,
Area.
area, then
Mass.
mass.
Time.
Next,
Time.
Distance.
volume,
Distance.
Sir, sound.
yeah, unwanted. Volume. And we are going to learn some physical quantities. Adunu nan mention ಮಾಡಬಹುದು. Right. Distance. Afterwards, we'll come to know why that distance is scalar quantity. Underline that. Next, speed. Yes. Yes. Next, vector quantity. Right. Vector quantity. Vector quantity. Write the definition of it. The physical quantity that has both magnitude and direction. That has both magnitude and direction. The physical quantity that has both magnitude and direction is called vector quantity. It's called vector quantity. Let's go for taking few examples.
Weight.
Examples, huh? Yes.
Force.
Weight.
Force.
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 Displacement. Velocity.
Pressure.
Wait,
Pressure.
wait. Underline that.
Velocity.
Velocity. Afterwards, we'll discuss about all this. Velocity.
Energy.
Etc.
Pressure, sir.
Pressure, no. Pressure won't come.
Excuse.
Over. Okay. Dear students, in this chapter, that is in the chapter in the chapter motion, we will discuss about some physical quantities in detail. We have already underlined them. It may be the distance, speed, displacement, velocity, even some more terms are there like acceleration, deceleration. Now let's go for focusing on one by one. Look here. Have you copied this? Okay.
Yes, sir.
I am going to take a situation. In that situation, assume that a boy is moving from his home to school. This is his home. And here is the school. When he is moving from his home to his school, whatever the path he uses on which he will be moving. Shreyas, look here. you'll come across different turnings also, because it will not always be straight. You may go here, then you may take turn here, then you will come across some other roads, finally reaches the school. See, this is the path on which a boy has moved to reach to the school. If you go for finding the length of this path, and we call this length as distance. Got it? Followed or not? Or else I'll give
Yes, sir.
one simple activity. Okay. Assume that there is an ant. Call this its position as A. You have assume that you have put just a drop of water here. Then what ant will, when it is moving, it will just carry some drops of water. Is it not? And look here, this is, it moves like this, and it comes here, then goes here. Yeah. This is the path on which ant has moved. Got it? If you go for finding the length of this path, and we call this as distance.
Distance.
This is our distance of the correct. The length of the actual path traveled by a body is called distance. Shreyas, you're not concentrating. Don't go for writing anything. Just sit properly. The length of actual path on which a body has traveled, this is called distance. And okay, this A is called, it is the initial position of the ant. And this is B is called, it is final position or terminating position of the ant. And this is the path. And the length of this path is distance. You may go for taking the direct distance from A to B.
Displacement.
If you go for taking the direct distance between initial
Displacement.
position and final position of a body, this is called displacement. Followed. And
Sir,
if
tell
you are
again,
taking
sir.
an example, okay. A boy is moved from his home to the school by moving on the different roads. If you go for finding the length of the path on which the boy has moved, it is called the distance. And if you go for finding the direct distance from his home to the school, in between many buildings may come. If you go for considering the direct distance, then we call that as displacement. Got it? In between, you may come across the big buildings and all. We won't consider all those. Direct distance is considered, then it is displacement. So these are the two important physical quantities about which we are going to get information. Just look here. Once I tell the definition of distance and displacement, the length of actual path traveled by a body, the length of actual path traveled by a body is called distance, and distance is denoted by the symbol small d. Next, the direct distance between initial position and final position of a body. The direct distance between initial position and final position of a body is called displacement. And displacement.
Sir, can we say shortest?
Oh, yes. Yes.
Sir, can we say shortest?
It is the shortest distance between the initial position and final position of a body. This distance can be measured by using the unit that is called centimeter, meter, kilometer, miles, and so on. But among these, one unit is accepted internationally.
Meter.
Meter. And meter is called the SI unit of distance. Do you know the full form of SI?
System of international.
System of international units.
System of international.
Very good.
International.
System of
Standard unit.
Enough, enough.
System of international.
System of international unit. That is SI unit. SI unit of distance. It is meter and is written as just M. Then SI unit of displacement. SI unit of displacement. That is also same. It is
Meter.
meter. This is the
Meter.
similarity between distance and displacement. Both are having same SI unit. Next, here, when you start moving, assume that this is my initial position. If I start moving, the distance covered by me will go on increasing or decreasing.
Increasing.
It will be
Increasing.
It will be increasing.
Increasing.
increasing, and this will always be positive. And example, suppose you have moved for some distance. You can say that I have moved a distance of 100 meter. Do you say that I have moved a distance of minus 100 meter? Are it ಹೇಳ್ತೀರಾ?
No, sir.
No.
No, sir.
No, sir.
Distance
No,
is
sir.
always positive.
No,
Distance
sir.
is always positive. And observe my position. Now I am not at all moving. What is the distance covered by me?
Zero.
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 Zero. Zero. Zero.
Zero. Positive. Distance may be zero. When the body is at rest, the distance covered by it is zero. When a body starts moving, the distance covered by it will be positive.
Pause it.
But it distance may be zero or positive. What about the displacement? Look here. Here it is the direct distance between, or the shortest distance between initial position and final position. Assume that the body is at rest. It is not at all moving like we know. What is the displacement? Displacement of mind.
Zero.
Zero. Zero.
Zero. Zero.
Zero.
Displacement may be zero. Now, assume that I am moving in a straight line. Now, I have covered a distance of just 3 meters. Could you tell what is my displacement?
3 meter.
Positive.
3 meters.
Positive.
3 meter.
3
I
meter.
told you that I have been moving in a straight line. A straight line and move ಆಗ್ತಾ ಇದ್ದೀನಿ. So this is displacement. My displacement is 3 meter. So if I start moving and attain the final position, you'll find the displacement. That displacement is positive. Got it? Look here. This is my position. I start moving just 2 meter in a straight line. 1, then 2 meter. Now I'm coming back on the same path. 1, 2, 3 meter. Now could you tell what is the distance covered by me?
3 meter.
Minus
5 meter.
Minus 1.
5 meter.
5 meter.
5 meter.
6
6
meter.
meter. 5
Observe.
meter.
First I moved 2 meter on a straight line. Then I come back by 3 meter on the same straight line. Same path. The total distance is 5 meter. But what is my displacement?
1 meter. 1 meter.
Minus 1 meter.
1.
minus 1 meter.
Minus 1
Very good.
meter.
Here we
Minus
consider
1 meter.
minus 1 meter. Here, I'll just show you. Okay, this is my initial position. If I move forward, it is positive. If I move backward, it is negative. Got it? So here I moved a distance of 2 meter, 1 meter, here 1 meter. Forward distance. Then I turned back and then I started moving 1 meter, 1 meter, here 1 meter. This is my initial position, sorry, final position. If you want to find out the distance, you have to consider this 2 meter, then 3 meter. 2 plus 3, it is 5 meter. This is distance. And displacement, direct distance, shortest distance between initial position and final position. How much it is?
-1 meter.
-1 meter.
-1 meter.
Plus 1 meter.
minus 1 meter.
The minus sign here indicate ಮಾಡುತ್ತೆ ಅಂದ್ರೆ I have moved backward. Got it? So from this we can say that displacement may be negative. So yes, don't try it. Afterwards, I'll give you the points. Now you just go through the distance. Maybe 0 or positive. Displacement may be 0, positive, even negative. Next, one more. I'm sorry, yeah. Assume that there are two places, A and B. There are two places. One place is A and another place is B. Could you tell how many paths are there to move from A to B?
Infinite.
Infinite. I may move like this on this one. I may move in this one. I can move like this also. Then I can move directly from A to B. See, these are the different paths. If you go for finding the length of actual path traveled by a body, it is considered as distance.
Distance.
So the distance between two positions, will it be same or different?
Different, sir.
The distance between 2 points will be same or different?
Same.
Different, sir.
Different, sir. Different.
Listen here.
Different.
Listen. Assume that you will move from your home to your school. Shreyas. You'll move from your home to your school. Will you always move in one same path only all the days?
No,
No,
No.
sir.
no, sir.
No,
Change
sir.
some roads as well. But initial position, your home is same. Final position, your school is same. But the path used by you is different. Hence, distance between 2 points will always be different.
Different.
Whereas displacement between your home and school, or school
Will be same.
and home, will it be
Always
same
same.
or different?
Same.
Will always be same. He directed, if A in the B ಗೆ ಹೋದ್ರು ಅಷ್ಟೇ ಬರ್ತಿರುತ್ತೆ. From B to A also it is same. Hence you can say that distance between two same points may be different, whereas displacement between two same points is always same. Followed? Don't try it. Afterwards I'll give you the points. And you just ಕೇಳಿಸ್ಕೊಳ್ಳಿ. Okay, this is my initial position. I start moving here up to here, then I see just I'm moving here again. I come back to my position. Now could you tell what is my displacement?
0.
0.
0.
Zero.
My initial position and final position is same. When the initial position and final position of a body is same, the displacement will be 0.
0.
Now I go for taking this object. It is a duster. From here, I'll throw it vertically upward. Assume that it reaches to a height of 2 meters. Then it comes back. It comes back to my hand. Now,
Distance
could you
will be
tell
4 meter.
what is the distance covered by this
4
duster?
meter.
4 meter.
4 meters.
First 2 meter, then 2 meter.
2 meter.
4
In
meter.
upward direction, it has covered 2 meter distance. In downward direction, it has covered 2 meter. Total distance is 4 meter.
4 meter.
What about the displacement of this duster?
Zero.
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 Very good. It's because it's initial position and final position. Both
They
are
are same.
same. Now, listen. Look here. Here we have a straight path. On the straight line, I'm moving. I start moving from here. Hope that you're all able to see me. Can you all see?
Sir.
Sir.
Yes, sir.
This is my
No, sir.
initial position.
No,
I
sir.
start moving from here. 1 meter, 2 meter, 3 meter, 4 meter. Got it? Then I'm turning back. Again, I'm now
Sir,
put it
Sir,
8
unwanted
meter.
sound.
8 meter.
Sir, unwanted sound is coming.
Sir, someone is unmuted, sir.
For me. Yes. Okay. Listen. Listen. First I moved for 4 meter distance on the same path. Again, I can't come back to
4
the same
meter.
position. Then total distance covered by
8
me.
meters.
8 meter.
8 meters.
Meters.
8 meter.
8 meter.
8
Displacement.
meter.
0.
0 meter.
Zero.
Zero.
Clear up? Again, just observe. It's my initial position. I start moving. 1 meter, 2 meter, 3 meter, 4 meter. Now, could you tell what is the distance covered by me?
4 meters.
4 meter.
4 meter.
Displacement
4
also 4
meter.
meter.
Displacement also 4 meter.
What is my displacement?
4
4
meter.
meters.
4 meter.
4 meter.
4
4
meters.
meters.
Here, listen to me carefully. Here, the distance is 4 meter. Displacement is also 4 meter. Could you tell under what condition distance and displacement both will be same?
When both are in straight
When the
line.
initial point and the final point will not be
Final point will be
Salah.
same.
Dheeraj,
And
Dheeraj SK, you can tell.
Sir, in same path we will move means both
Very
are
good.
same.
When a body moves along a straight line, when a body moves along a straight line, distance ಮತ್ತು displacement ಎರಡೂ same ಇದೆ. ನಾನೀಗ 10 meter move ಆದ್ರೆ distance is 10 meter, displacement is also 10 meter. Got it? But if I change the direction, ಅವಾಗ distance and displacement get changed. Okay, now let us write about distance and displacement. Right? Side heading, some important physical quantities. Side heading. Side heading, some important physical quantities. Some important physical quantities. In that, first one, write distance. Distance. Write its definition. The length of actual path traveled by a body. The length of actual path traveled by a body is called distance or distance traveled. Distance traveled. And in bracket you may write, it is denoted by the symbol small d. Next one. Just below that, it's SI unit. Write it as point wise. It's SI unit. SI unit is It is meter. M-E-T-E-R. In bracket you may write small m. Meter. Next. It may be 0 or positive. It may be 0 or positive. Listen, when you are finding the distance, will you consider the direction?
No, sir.
No, sir.
Consider the direction.
No, sir.
No, sir. No, sir.
However we want, we can move. So that is why it has distance has only magnitude. If it has magnitude, what type of physical quantity?
Scalar.
Scalar quantity.
Scalar physical quantity.
Scalar quantity.
It is a scalar quantity. It is a scalar quantity. Next, distance between 2 points. 2 points will be same or different?
Different.
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 2 points is different. Next. Any other point which we come across?
It is scalar quantity.
Huh?
It is scalar quantity.
It can be measured by distance traveled by a body can be measured by using a device called odometer. The vehicle it will be there. You might have observed that.
Yes, sir.
Odometer. Right. It is measured by using the device odometer. Next.
Sir, what is odometer, sir?
Odometer, that is a device which is installed in the vehicle. Let me show you that. In the bike, scooty and all, you may observe that there will be
Yes, sir.
a
Speed
structure like this, and also there will be a
gauge.
needle, and here is a measuring scale. In this measuring scale, it will show that wait, it is mentioned here. You can notice that this will show speed and all, but just consider only this line. Here some numbers are written. I have written
Kilometer
12360, 12360, and
Yes,
there
sir.
is unit also, kilometer. It will show how much distance you have traveled using that vehicle.
Bike or scooter.
So this is odometer. Odometer is a device which is installed in the vehicle to measure the distance covered by the vehicle. Next, right, second one, quickly. It is displacement. Right. The shortest distance between the direct distance between, both are same one. The direct distance between initial position and final position of a body. Is called displacement. The shortest distance between initial position and final position of a body is called displacement. Here in bracket you write yes. Yes represents displacement. You can also represent like this. Okay. D over the arrow. Did you understand? That in displacement ke direction irutte. As we are going to take the direct difference. So that is why we'll show with an arrow mark. Next, what is this uncertainty?
Small letter S or big letter sir?
Huh?
All letter.
Small letter. Right, and SI unit. SI
Meter
unit
only.
is SI unit is meter.
Meter.
Meter. Next. Right, this point. It may be 0, positive or negative. It may be 0, positive or negative. Next. Could you tell what type of quantity it is?
Vector quantity.
Vector quantity.
Vector
quantity.
Right.
Vector quantity.
Prajwal SM. Prajwal SM. Could you tell why it is vector quantity?
Both magnitudes.
Because it has
Magnitude and direction.
both magnitude
Has magnitude and also directions.
direction kuda mention ಮಾಡ್ತೀವಿ, and also how much distance
Magnitude.
that will also magnitude will also be mentioned.
Count.
It is a vector quantity, right? Vector quantity. Vector quantity. Next. Right. Displacement of a body will always be same. Or displacement between 2 points. Displacement between 2 points will always be same. Will always be same. Written up. Okay. Written.
Yes, sir.
Okay. Now it is time up.
Yes, sir.
Dear students, tomorrow you will be having the weekly test and timing will be given within 12 o'clock only. I'll send the message in the group and go through that.
Sir, including science also, sir. Sir, math, sir.
Yes, both maths and science will be there. Both maths and science will be there. Mathematics, only the additional problems. Only the additional problems. Okay. Other than textbook, I've given you so many examples. So from those, test will be given. And science up to displacement. Got it? Okay. Timing, I'll give you that information in the group message only.
Sir, by
So-
Google form.
Huh? Hey, not
Google-
Google. On every Sunday, you will be having written format test. Google form, I want to enhance your thinking skill so that yesterday just I implemented. In forthcoming week, it will be continued. Okay. So with this, let us stop the class. Thank you very much.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.